Makes sense to do some introductions. So to start with me, my name is Danielle Vass. I am a software engineer, Android developer for sort of 12 years now. I've done quite a lot of open source things previously, but I've been at Spotify now for 2 years. And these are my two fur babies. Their names are Beatrix and Powder. You can tell by their facial expressions which one gives me more trouble. Thank you.
Hey everyone, I'm Walid. I'm an embedded software engineer. Originally, I worked in the automotive industry for 4 years for companies like Stellantis, so Peugeot, Vauxhall, and whatnot. And then more recently for Volvo and Polestar. A little over 2 years ago, I joined Spotify as a quality engineer to help automotive companies and smart speaker companies build the best Spotify experience. And that's my only cat, and you can tell she doesn't give about anything. So yeah, she just likes sleeping. So let's talk a little bit about how we build Spotify for Android Automotive. So let's cover our basics. Spotify is a music and video streaming app that exists on a lot of your devices that are not phone or laptop, like smartwatch, but more importantly to our talk today, car, and more specifically, cars that run on Android Automotive. So you might be wondering, what is Android Automotive?
Yeah, so this is me. Android Automotive is installed directly in the car. So this means you don't need a phone to run anything. If you're using your phone to control your head unit, that is usually something called Android Auto, which is different to Android Automotive. Or you may be using CarPlay if you've got an iPhone. The important differentiation here is that the car has its own network connection and the car has its own battery. So that makes it super interesting for what we can do and what our customers may want to do. It's also really useful for us because there are a lot of driver distraction things built in for us. We don't have to necessarily worry about that. Android Automotive has handled a lot of that for us. So what is Android Automotive? So fundamentally, it's built on Android, and this is really useful for a lot of reasons. So for one, there's already a lot of developers that already know Android. So there's a lot of us in the room that can already write Android code. So this is really useful for a lot of manufacturers. Android is also open source. So for a lot of manufacturers that may want to do their own thing, they can have a look, they can fork it, they can do what they want. And then finally, it's super customizable, which means that car manufacturers can make it feel like that car manufacturer. You know, a different experience in one car can be completely different to another car. The other really important thing for us to differentiate at this point is that there are cars that run Google, which are cars that run Android Automotive that run with GAS. So this is Google Application Services, and there are cars that don't have GAS. So what is GAS? GAS is advertised as cars with Google built in. There are a bunch of apps and services that are built in that are just inside the car. So for example, you've got the Play Store, you've got Google Maps, you've got Google Assistant, but importantly for us, there is the Google Media services. Some examples of cars that already have it, and sorry, the screenshot on the right is not super visible, but like a Polestar has Android Automotive with GAS. Renault have some cars with Android Automotive running, so you can see on the right, there's the Spotify app, you've got the Play Store. And then for our friends in America, like General Motors, you've got Cadillac Lyriq, for example, they have Android Automotive with GAS. We then move on to some fun ones where there are no GAS. This is interesting for us because there's no Play Store. There are other app stores available, and there are other ways which we ship, which is direct to manufacturers. Our app at this point basically becomes an SDK, and that means that we also maintain developer documentation for how to integrate with our app, which is fun. So for some examples of car manufacturers that don't have GAS, so you've got, for example, this is a Mini that has been released this year. You've got a Rivian for our friends in the States. They have their own embedded Android Automotive experience. And then I really like this to show us the customization. The Mini that was released this year has Android Automotive, non-GAS. And yeah, I think it really demonstrates how customizable you can make this experience. So for anybody super interested in the market of getting a new car, there is a Wikipedia article that has a list of all the vehicles with non-GAS and GAS. So if you're in the market to spend a lot of money, there is a really handy webpage that can help you buy or find a car if that is the only differentiating factor that you want in your new car. Thank you.
So for Android developers, the point of reference for a lot of us is mobile development. So we're going to do a little comparison here to show you how different development for the two products are. The R&D for an Android phone is 12 to 18 months, while a car is 3 to 5 years. So it's almost 3 times the period, as well as for the lifetime of the device itself, it's 5 to 6 times. So there's a lot more things that you need to take into consideration when writing or developing an app for the car. One of which is, how is your app going to look like in 12 to 15 years? Because that's how long the car is going to look like. Of course, cars come with software updates, but it's the same hardware that are going to run your app for 15 years, and you have to take that into account. Speaking about software updates, we're going to give you a sneak peek about what the distribution of OS versions that iOS or Android Automotive Spotify users are actually using as of October this month. And you can see that a third is using version 9, 11, and 10, while the vast majority are on Android 12, and we know that's like 3 years old. So you have to take that into account, and you have to take this restriction that updating the OS on a car is not as easy as it is on a phone. Which leads us, which is a great segue to how we build our app.
Thank you. So yeah, I think that for a lot of Android developers is like an interesting challenge that we have to look at. So as a Spotify app, we are a media app. We make use of Google's media APIs. This means that we don't really own any of our UI. We only own 2 screens completely, and that is our login screen and our settings screens. Everything else we provide the data for, but we handle manufacturers or Google decide how they want to render that. So here is an example of like our home screen, for example. So media templates are handling rendering all of the screen. So we provide a list of items for that screen to show. We don't care how it gets rendered. We pass it on to other people. Templates are, again, really useful for us because they abide by driver distraction rules. We can be confident that we aren't going to cause any issues for our drivers because they've gone through a lot of rigorous testing before they've hit us. So how do we go about displaying something? So for example, on the home feed, we had an item called Daily Mix. We can provide a thing called a media item, and we can provide a list of media items. So what sort of items can we put inside there? So we've got a bunch of the standard things like a title, subtitle, description. We also provide an icon URI so that we can say like how should this look? We provide a media ID. So this is mostly useful for us in Spotify to say like, is this a piece of content that should display more content? Is this a piece of content that should start playing, for example? We know then what content should be playing or what content we should be showing you. We then also can provide you a bunch of extras. And by a bunch of extras, I mean we provide a bunch of extras. So at the top, we can indicate how we want this item to display. So we get to control how items display for browsing content and playing content. So the example on the left, this is my home screen. Each of those items is browsable, and we're rendering it in a grid. If I want to go down one level and click on like a playlist, for example, I then can see each song rendering as a row. And that means that that item is playable. This works because I'm a premium customer and I can navigate and play individual tracks. If I was a free customer, this changes so that the grid items are playable. We don't let free users select individual tracks. They can play an individual playlist, for example. So this is how we can customize how we want those items to look. We can also provide a header. So for example, our home feed is divided into chunks. So for example, at the top, we have a good morning. We have the top like things that you might want to say. So for each item we present, we can give it a header, and the media center handles grouping those for us. We are also good citizens. We handle making sure that we mark things as explicit. We also handle that is 19 plus for our friends in South Korea. This means that if you're in the car with kids and maybe you don't want to play explicit content, you can very clearly see which content is safe and not safe to play. For content that is longer form, like podcasts and audiobooks, we handle displaying like either how much is left to play, whether you have played that content before, or like how much would that be. So if you've got a specific duration of your journey and you're trying to find some content, this really helps you inform like what would be long enough for your journey. So yeah, to reiterate, when you ask for a specific thing like home, We just provide you a list of media items. And so then if you ask for a second thing, so for example, here we've clicked on the playlist, again, we just provide you a list of items. We are basically just lists of items all the way down. So this kind of concludes like how we can browse and see content. What if we want to play content? So at Spotify, we have a Spotify library that handles playing content. This is across most of our apps will use it. Automotive app is one of those apps. The Spotify library handles playing content. It handles like restrictions. So for example, free users cannot play specific tracks. If you've got audiobook like tiers on your thing, it will handle how many hours of that you can listen to before it stops. This means that we then don't have to maintain a lot of that ourselves, but we can pass the media items to our player to play. We also have a now playing view that we can control. So this is an example of a now playing view for a piece of music. At the bottom, we have the standard media controls. So you've got play, pause, you've got next, back. We also have two custom actions which are specific for our app. So on the left, you've got the add to collection, remove to collection. We also have a shuffle button. For podcasts and audiobooks, we changed that up a little bit. So you can see instead of the previous and back, we've got rewind 15 seconds, go forwards 15 seconds. We then have an overflow menu on the right, which allows people to control things like playback speeds and like maybe going to the previous and next content. We get to customize so we have to provide these in the order that we want them to display. So we think the items that are in the overflow menu are things that people may want but may not use every day. So then just to reiterate, we look at every playing item that's playing, and we then pass a bunch of custom commands across to the session player. The green items are things Spotify owns, so we look at what's currently playing. We then pass a bunch of commands to the session player to then update what should display on the screen. So for the examples that we went through, we've got the music item. We then pass the like, previous, play, next, shuffle button. They are the ones that then appear on the screen. And so for a podcast item, we then provide a bunch extra custom commands, and they obviously get displayed in the order specified here. We then have a callback, so the session callback will let us know if a button is pressed. We then handle that inside to say like what should happen when that button is pressed, and then we update the session player accordingly. So an example here would be a customer has pressed the next button. Spotify has to decide what does next mean. Does that mean the next item in the playlist, next podcast? Like what does next, what makes sensible to go next? We then determine that, we update the session player based on that. An interesting point here is that for a lot of our non-GAS friends, so people that have written their own custom media centers, we have to provide documentation to how to use those custom actions. So that's something as engineers, if we add new items, we have to update our documentation. If we change any of these things, all of our non-GAS friends will have to look at that and update their UIs depending on what we've done. So cool, we now can see content and we can now also play content. Let's maybe look at how we would add a new feature like AI DJ. So for friends that haven't heard of AI DJ, the DJ is a personalized AI guide that knows you and your music taste so well that it can choose what to play for you. You get a little bit of preamble introducing you to some content, followed with a couple of tracks before it then changes up and plays something completely different. It's currently available in like 50 markets and like 2 languages, so it's available in English and Spanish. So for browsing AI DJ, we obviously have to add a media item. We have to have an icon, we have to have a title, and we have to make sure that that media ID hooks back into something that we expect to translate to this is AI DJ. When the AI DJ is playing, we also provide a custom action. So down here on the right, we have affectionately known as the jellyfish icon. I don't think that's the official terminology. But we add that to enable people to switch up their contexts. So maybe you're in a playlist or a group of songs that you're not really interested, you can hit that button, you get a whole new context. So we handle this callback in exactly the same way that we mentioned earlier, but the interesting thing for us here is that you are still playing music, so we have to differentiate, is this music that's coming from a standard playlist or a standard album versus is this music that's coming from AI DJ? So that is adding AI DJ. The last slide that I've got as part of building is that we have a huge challenge from emulators versus real devices. So My background as a traditional Android engineer is that we've had test labs with phones that you can just check out to debug problems on specific platforms. That's not super appropriate because cars are really expensive. We can't just have every single car that we support in our garage. Like, that's just not feasible. So we have to rely on like emulators. We also have to rely on our partners and our friends to like help test us. But that's also a super challenge because not all of the Android Automotive non-gas platforms support having a beta app. So that means we have to ship something to production to be able to tell if that works in that vehicle. And then the final point here for a lot of us privileged Apple developers, so I have an Apple Silicon laptop. Almost none of the emulators work on this laptop. I have to have a separate Intel laptop purely just to run emulators that can help me determine if these systems are working. Obviously, there's nuances with running emulators. You don't get necessarily all of the feedback of something's working. You also don't get the feedback of like actually what it's like to be driving and using an infotainment unit. So yeah, there's a lot of like interesting problems here. Thank you.
All right, that leads us into how we test our app. And when we say we, I don't mean Spotify or the app developer in general, but also the two very important stakeholders that allow us to get an app to the market, which is one, Google, and two, the manufacturer. And it's a collaborative effort to kind of make sure that the app is driver safe, secure, and it actually works. And these are the three important scopes that we need to get through before an app hits the market. Let's start with driver safety. And the principle here is very simple. How do we make an app that doesn't take too much attention from the driver and allows for, while using it, safe driving? And Google has offered a set of UX restrictions that basically, if you follow them, it means that your app is driver optimized and can be used while the car is moving. And they can be organized in a set like in configurations, which means different laws for different regions, and your app can follow these configurations one at a time. And whether your app can run or not depends on what we call driving state. It takes as input the gear selection and vehicle speed. So when your car is parked, you can basically do whatever you want. And this is when video streaming apps shine or actually work, or video gaming like in the car. This is when you can use it. Moving is fully restricted, where all of the UX restrictions apply, and it could be something like the number of characters you can show on a screen, how complicated a menu can be, anything that would take attention away from the actual road and driving. And idling is like a gray area between both, where, for example, you can still have a keyboard and type your destination in Google Maps, or do something similar that while it takes your attention for a little bit, you can quickly go back to driving. And you can see that you can declare if your app is driver optimized. It means it can run while the vehicle is moving. And the whole app does not have to be driver optimized. It's per activity. So you can have a mix of activities that can run while the app is moving, but others that have to be restricted to only parked mode. And you can test how your app behaves, depending on speed or not, by either injecting values that emulate the speed vehicle and gear selection, either through ADB or through the emulator's UI that allows you to change these values either through the quick menu there, extended controls, or directly through the vehicle hardware abstraction layer, which we'll talk about in a bit. Moving on, security, because who wants to be in a metal box that weighs a few tons and runs at 100 kilometers per hour if the computers running it are not secure? So here we have some core security principles that we need to follow that allows us to kind of have a peace of mind when having systems like Android controlling a big part of the vehicle's functions. First one is system-level isolation, and this is where our apps and APIs are restricted in what they can do within the car and what communication they can have. Some OEMs even, or some car manufacturers, they even have whitelisting for IP addresses that you can communicate to. So as an app developer, you kind of have very restricted of what you can do and what APIs you can call. We also have car services, which is like the services that manage the infotainment and navigation, and they run in an isolated environment that doesn't allow them to interfere with critical car functions. And my favorite, which I think it's the fail-safe, it's the vehicle hardware abstraction layer, which is kind of a secure bridge between the hardware and the software. So if there's any issue with corrupt data or like malware within the software, it does not reach the hardware, the sensors, or the sensitive vehicle functions. And the second one is the principle of least privilege. Basically, as developers, we hate this, but it's a very easy thing to implement, and it increases or decreases the chances of having malware. So basically, anything in the car is on a need-to-know basis. Sandboxing is pretty standard, which each app runs in its own isolated environment, and it prevents apps from accessing each other's data and messing with core or like sensitive automotive functions. And last is data security, where we aim, or where the platform aims to secure the user's data, usually through encryption. But the special thing about Android Automotive is that it uses vehicle-bound encryption, which is where the keys generated to encrypt the data use seeds that are bound to the vehicle and not the user. And as an extra layer or an extra measure of security, these seeds are not stored on the computer that runs Android Automotive, but on other computers in the vehicle. So that in case of theft or dismantling the infotainment system, that data is useless, and if you have access to the memory, you can't inject false data that you can use to start the car and run away with it. Which leads us to the third aspect, which is functionality, basically making sure that the app actually works. And here we're not going to talk about partners or manufacturers that use Google Automotive Services, because they sort of get the app directly from the App Store. But I want to talk about a more interesting use case, which is the non-gas partners, because then it's a collaborative effort. Our APK, as Danielle mentioned, becomes sort of an SDK or a headless app, if you will. And then the partner integrates it into their infotainment system. So basically, they build the experience even though we build the app. And for that, we have to make sure that that app looks like Spotify and not like a random thing in their infotainment system. And for that, we have a certification process that we've set up and make sure that the app looks exactly like we want it. The process, when there's an evaluation process with like business and the legal teams, but once that's cleared, we sign a partnership agreement, and the flag is handed over to our team where we onboard the partners. We give them access to our tools, our documentation, our APK, and then they can start to building and testing. Once that's done, they hand it over to us, and we either, as Danielle said, if we're lucky, we test on the vehicle. Most times, or like we like to test on a bench if that's possible, but most times we just use emulators that the partners provide for us. If everything's clear, we sign a distribution agreement that allows the partner and the manufacturer to go to market with that solution that we built together. And we see here that there's a closer loop or smaller loop that keeps repeating with each project and each car they launch. Our requirements can be separated into three main themes. Functional, basically how the app works. We control most of that, but there is room for the partner to mess that up because, again, we build the APK. The second one is the design requirements, and this is where the partner has most of the responsibility, and we have to check that they satisfy Spotify's design requirements. And the third one is legal and marketing, is basically what the app looks like in their infotainment system and outside of it, like when they market it, what does it look like? And last, when they launch, as we touched on before, the app is going to live for a very long time in that car, and we need to agree with the partner. How are they going to maintain it? How are they going to maintain the platform that runs under it? And in case we added a feature like the AI DJ, they have to collaborate with us so they can reach their audience as well. Which leads us to how we release our app.
Yeah, so now we have a lot of code that we want to give to people. How do we send it? So the easiest way we send it is the gas releases. So this is probably something everybody else in the room has already done. We use the Play Store. We kind of cut our releases every 2 months. It can be more often, it can be less often, but we aim to do it sort of every 2 or 3 months. We aim to do phased rollout. So again, because we haven't been able to test on a lot of vehicles, we try and minimize the number of people we roll out to start with. And we do a lot of monitoring to make sure there are nothing surprising that we didn't anticipate beforehand. We have to be super mindful that it can be slow to update. So typically people will leave their cars in garages or outside their houses, where they don't have reliable Wi-Fi or like network connections. So actually their car will update maybe the next journey they take. And actually it's the journey after that when they actually get our updated experience. So if we do make problems, it can be really slow for us to get fixes out there in front of people. The other really useful thing at this point is to say that the car manufacturers at this point have very limited control. If we, Spotify, decide that we want to make an app update, we can ship it. It doesn't really matter what they say at this point. We can send it, and we can send it to the number of people we want to send it to, and we can control a lot of that. We also make good use of the Canary feature or beta program inside the Play Store. So we cut this automated weekly. This lets us know if there are any potential issues upcoming. We then have a lot of relationships with our manufacturer friends. This means that they have access to our Canary. They can give us feedback before we start cutting a main release. But we have some difficulties with that. So the Play Store in a vehicle doesn't allow for custom domains. You have to use an @Gmail account. This means we can't just whitelist everybody as a Spotify user or a Spotify employee. We have to maintain our own Google group that has a list of people that should do it. If people leave the company, we have to remove them, and it requires us to maintain that. Likewise, for our partners or our manufacturer friends, they have to maintain their lists of people that should have access to our early releases. Now we move to the fun ones. So we obviously release to other stores and direct to manufacturers. We also provide a changelog. So because they have developer documentation, they likely have to make changes. We have to make a changelog that is developer friendly and human friendly. We again have relationships with manufacturers. They have access to a lot of these vehicles. We don't necessarily have access to all of these vehicles, so that feedback is really, really important to us. They also have their own testing programs, and these testing programs can take from a week to some manufacturers take 6 months for us to give them our APK for it then to roll out in cars. So that somewhat explains why we don't cut more frequently. And again, at this point, it's useful to point out that we have such limited control at this point. As soon as we pass the APK from our side to their side, we don't get to control any of this. They get to decide when it rolls out to their vehicles. They get to decide if they ship it to their vehicles. It's also useful, I think, at this point to consider there are other updates outside of Spotify. So there is also the Android operating system. There are discussions going on about how do we update Android in a car. We also have the Media Center, so we rely really heavily on Media Center. So if Google or other people make updates to their Media Center, we have to be aware of how many people have that. If we're building features for the latest Media Center, but actually no cars are out there with it yet, is that really useful for us to have done? And then finally, Spotify will push updates. And so manufacturers will decide really on their schedule when they push a lot of these updates. So they may bundle a bunch of these together, and you may just have a package of updates on your car, and we get updated at some point alongside everything else that could get updated. Cool, thank you.
All right, so I want to end this a little bit on an inspiring note, and the title is we are in a very exciting time in the automotive space, especially when it comes to infotainment. More companies or more manufacturers are adopting Android Automotive, and it's accelerating fast. Pair that with the fact that self-driving cars are becoming more reality than sci-fi, so the drivers are awarded a little bit more freedom on what they can do in the car. And there's this term that I hear floating around that I really like, is that the car is turning into a living room on wheels. Car infotainment now is evolving very fast, and there's a lot of room for creativity. Car manufacturers do not know what the future of car infotainment is going to look like. Is it going to be one screen, horizontal, vertical, or rotating one like BYD does, or a very huge one like Cadillac does in the front? There's back speakers, screens. There is premium speakers, which is very expensive R&D for the car companies, but it's a very exciting time for consumers and for developers. So next time you're waiting for a PR to merge and you have Android Studio open, pop that Android Automotive emulator, and let your creativity run wild, explore the new features, and who knows, maybe that might be just the next big thing in automotive. Thank you, everyone.
Thank you, everyone.